Hi there. We looked today in class at the derivative rule for e to the n, and this rule you can find both on the notes that are uploaded to my website as well as on the derivative and integrals rule paper that we passed out and looked at in class, which the derivative rule for e to the n is e to the n. You literally rewrite the function as it is, and then you multiply it by the derivative of n, or the derivative of the exponent. And so I've selected 3 problems to demonstrate these procedures, kind of increasing in difficulty as we go. The first one's a pretty basic one here. It's number 38 from the book, y equals e to the 2x, and y equals e to the negative 2x. They're asking us to find the slope of the tangent line at the point 0, 1 for both of these functions. And remember, when they ask you for slope of the tangent line, that's aka derivative. So we need to take the derivative here. So we have the derivative of y. And in this case, my y is an e function, so we're going to go ahead and apply our rule. Derivative of e is e to the n, so literally rewritten, times the derivative of my n, which in this case my n is 2x, and the derivative of 2x is 2. Okay? To find the slope at this point, we're going to take our xy coordinate, we're going to plug it into our derivative here. Right. And in this case, 2 times 0 is 0. We have e to the 0, and anything to the 0 is 1. And so my slope here is 1 times 2, or 2. Okay, another kind of that basic level. Again, slope of the tangent line, aka derivative. So we're going to start with the derivative. Derivative of e is e to the n times the derivative of n, which in this case n is negative 2x, and the derivative of negative 2x is negative 2. Okay. Again, to find the slope, we're going to go ahead and take our point and plug it into our derivative. Negative 2 times 0 is 0, e to the 0, anything to the 0 is 1, and 1 times negative 2 is negative 2. So that's just to demonstrate the rule itself. The next one, we're going to go ahead and look at the rule within the context of potentially other derivative rules. Because all these rules could theoretically be used together, right? You might see an e within a natural log, or an e within a product, e within a quotient, e within a chain, etc. Right? And so I've gone ahead and selected number 54 here, which shows a product rule in conjunction with our e. Because in this case, we have 2 functions being multiplied together. Right, so we're going to be doing 1d2 plus 2d1 here. Okay, derivative of y is dy dx, and we have 1, which is x. d2, the derivative of e is e to the n, times the derivative of my n, which in this case my n is that x, and the derivative of x is 1. So it's 1d2 plus 2, so e to the x, d1, the derivative of x is 1. And then back here we have just a standalone e, so derivative of e is e to the n times the derivative of n, the derivative of x is 1. Okay. And then I'm just going to rewrite this really quickly here, condensing what we have from our derivative, or our initial step of our derivative. And then I would recommend simplifying this a little bit further, because here we have an e to the x and a negative e to the x that would cancel. And so my derivative in this case would be x times e to the x. Okay. The last one I've selected shows implicit differentiation being used, or I should say e being used within the context of an implicit differentiation problem. Okay. Implicit differentiation, remember, we use whenever our y's are inside our function, whenever we're having to take the derivative of a y. And we acknowledge the fact that we've taken a derivative of a y by tacking on a dy dx. Right, so when I'm looking at this initial function here, I first notice that there is product rule. So we have 1 d2, derivative of e is e to the n, as it is, times the derivative of n, which the derivative of y is 1. And then because we just took the derivative of a y, we do need to tack on that dy dx. So it's 1 d2. Okay, plus 2, which is e to the y. d1, the derivative of x is 1. Derivative of 10x is 10. and the derivative of 3y is 3. And then again, because we just took the derivative of a y and getting that 3, we do need to tack on that dy dx. And then finally, don't forget about the right side of the equation as well. The derivative of 0 is 0. Okay. Again, I'm going to choose to rewrite this before I do anything else. Just kind of condensing it a little bit. Okay, so that's always step 1, is to take the derivative. Step 2, you're going to get rid of anything that doesn't have a dy dx attached. In this case, that's the e to the y. I'm going to subtract that over to the other side. And this negative 10, we're going to add this to the other side. Again, I'm just going to rewrite it. Okay. Step 3, you're going to factor out a dy dx if there is more than 1, which we do have 2 in this particular case, so we're going to go ahead and factor out that dy dx. Because what that is going to allow us to do is to divide over the remaining terms that are not dy dx terms. In this case, this is the x e to the y plus 3. We're going to be able to divide that over to the other side here. So we have dy dx equals 10 minus e to the y over x e to the y plus 3. And there's our answer.